Hello. In this video, we'll be discussing the quantum mechanical model of the atom. The central question we want to answer is, how are electrons contained within an atom? Okay, so first we have energy levels, which you might also hear them be called electron shells. Think of them as the largest division or the largest class that electrons can be categorized under or placed under. There's the first energy level, the second energy level, the third, the fourth, the fifth, the sixth, and the seventh. And as the energy level's number goes up, generally the electrons in the energy level are higher energy. So the fifth energy, an electron in the fifth energy level would have more energy than an electron in the second energy level. Okay, and the energy levels are actually themselves subdivided into things called orbitals or subshells. Think of subshells as basically blobs of 3D space that the electrons are most likely to be found in. And there are actually different types of orbitals, different types of subshells. There's an S subshell, a P subshell, a D subshell, and an F subshell. Okay, so we recall that subshells make up each energy level, but how exactly is this done? Well, the first energy level contains an S subshell. The first energy level is made of an S subshell. We could also think of it that way. The second energy level is made of an S subshell and a P subshell. The third energy level is made of an S subshell, a P subshell, and a D subshell. The fourth energy level is made of an The fourth energy level is made of an S subshell, a P subshell, a D subshell, and an F subshell. The fifth energy level is made of an S subshell, a P subshell, a D subshell, and an F subshell. Technically, there can be an additional subshell in the fifth energy level, but that one's hardly ever used, so we just won't go there. We won't discuss it. The sixth energy level can have an S subshell, a P subshell, and a D subshell. It can also have an F subshell technically, also, in addition to the F subshell, it can also have two additional subshells, but those are never discussed, so we just won't discuss them either. The seventh energy level is made of the seventh energy level is made of an S subshell and a P subshell. Technically, it can also contain a D subshell and an F subshell, as well as three additional subshells, but those are never discussed much, and they're hardly ever used, so we just won't go there. We'll just discuss the subshells that are on screen. Okay, you'll be glad to learn that orbitals are further subdivided into things called orientations. Whoops. Yeah, that's just a note that these energy levels the upper subshells of these energy levels are hardly ever used or discussed in your introductory chemistry course, so we just won't discuss them. Okay, what was I saying? You'll be glad to learn that orbitals themselves are subdivided into things called orientations. Actually, orientations are what make up each subshell. Think of it this way. I know orientation sounds like it's a different version, but that can be kind of confusing. Orientation, if you think, sounds like it should be a different version of each subshell, but no. Orientations, think of them as blobs, and together you stick them on top of each other, and together they are called the entire subshell. Okay, so the S subshell only has one orientation, and it just happens to be spherical shaped. Those intersecting lines that go through it are just 3D axes, so you can picture it in 3D space. So there's our S orientation, the orientation of the S subshell. The P subshell has three orientations. They're shaped like dumbbells. Here's one, here's one, here's one, and together, all stuck on top of each other, they're called the p subshell. So remember, even though it looks weird, like it looks like one end of the dumbbell might be 1 and the other end, so you'd end up with 6, but no. The entire thing is called the p subshell, and then each blob, each dumbbell within it, each of the 3 dumbbell blob thingies is called an orientation. So keep that in mind. I always thought it was kind of difficult to understand that, but there you go. The d subshell has 5 orientations. They look kind of convoluted, so I'm not going to try to draw them, but know that altogether, the d subshell has 5 orientations. 5 blobby things make up the entire d subshell. Okay, and the f subshell has 7 orientations. I'm not going to draw them either because they look convoluted also, but you should know that 7 blobby thingies, or 7 orientations, make up the entire f subshell. Okay, so maybe you're asking where electrons come into play in all this. Well, each orientation, no matter what subshell it is of, be it an orientation of the s subshell, an orientation of the p subshell, whatever, each orientation can hold a maximum of 2 electrons, symbolized by E superscript minus. So the s subshell has 1 orientation, so it can hold 2 electrons maximum. The p subshell has 3 orientations, so it can hold a maximum of 3 times 2, 6 electrons. The d subshell, with its 5 orientations, can hold a maximum of 5 times 2, 10 electrons maximum. The f subshell has 7 orientations, so the f subshell can hold a maximum of 14 electrons, because 7 times 2 is 14. So, knowing that each energy level consists of certain subshells, and knowing that each type of subshell can hold a maximum number of electrons, we can figure out the total number of electrons that each energy level can hold. The first energy level has an s subshell. The s subshell has 2 electrons maximum, so the first energy level has 2 electrons maximum. The second energy level has an s subshell, which can hold 2 electrons, and a p subshell, which can hold 6 electrons. 2 plus 6 is 8, so the second energy level can hold a maximum of 8 electrons. The third energy level has an s subshell, which can hold 2, a p subshell, which can hold 6, and a d subshell, which can hold 10. 2 plus 6 plus 10 is 18, so the third energy level can hold a maximum of 18 electrons. The fourth energy level has an s subshell, which can hold 2, a p subshell, that can hold 6, and a d subshell, which can hold 10, and a f subshell, which can hold 14. 2 plus 6 plus 10 plus 14 turns out to be 32 electrons maximum for the fourth energy level. And we remember that the 5th, 6th, and 7th energy levels actually have additional electrons to them, or actually have additional subshells to them, so their maximum number of electrons are even greater than the energy levels before them. So we're not going to try to figure out their maximum number of electrons by looking at their constituent or subshells. But if we did want to find out for some reason, say a quiz question, we can use this handy dandy formula. Actually, you can use it to figure out the maximum number of electrons for any energy level. It is 2 times n squared equals the maximum number of electrons for the energy level, where n is the number that the energy level is called. So the 5th energy level can hold 2 times 5 for the 5th energy level squared. 2 times 5 squared is 2 times 25, which turns out to be 50. So using that formula, we can figure out that the 5th energy level can hold a max of 50 electrons. Okay, let's recap. Back to our original question. How are electrons contained within an atom? Okay, well, we know that the broadest category is energy level. and then under that is orbitals. Each energy level is made of orbitals. And then each orbital is made of orientations. And then each orientation, of course, can hold a maximum of 2 electrons. So I hope this video has been helpful to you. I always found it confusing in my chemistry course how there were all these different categories and all these different terms, and this was made up of that, and that was made up of this, and it was just really confusing for me. So I hope this video has been helpful to you, and goodbye.